Yes, I'd like to welcome everybody on board. And I promised in our earlier videos that we are going to discuss on the concept of polarity. And upon polarity, of course, is one of the major topics that is going to assist us in trying to predict whether the reactions are going to take place or not, especially in organic reactions. And basically, we're going to look at this particular concept in conjunction with what we had discussed on the concept of covalency. And we had said that valency, the covalent bonds are formed by sharing of electrons by atoms. So I've given an example of carbon whereby we said that carbon in actual sense is going to form bonds with, for instance, if just to give an example of hydrogens, and therefore it's going to form, methane is going to be formed through covalent sharing of the valence electrons with carbon. And therefore, this aspect of covalency is trying to portray a case whereby there's going to be equal sharing of these particular bonds. But from the periodic table, we're going to see that there's an aspect of electronegativity which is different for different elements. And therefore, that particular assumption from the covalency is going to create a difficulty for us in trying to figure out whether this particular case has the ability to, of course, stabilize the negative charge in this aspect. So therefore, as we're going to perform this concept of, or rather aspect of covalency, we're going to consider the aspect of electronegativity, which is one of the trends that we have discussed insofar as we have, of course, mentioned, not discussed, in one of our videos concerning the trends in the periodic table. And in this case, we're going to see that there's a particular trend, especially for the first two rows of the periodic table. And I'm just going to give just a affirmation over that particular trend, which is going to assist us in trying to understand the concept of polarity in relation to electronegativity that I've just mentioned. Now, in this particular case, if you try to consider the illustration that I've given on the board, we had said that carbon has the ability to bond to different heteroatoms. And in this case, I'm going to use the general illustration for X in reference to the heteroatoms that are mentioned. And therefore, these heteroatoms are going to differ in terms of this concept of electronegativity. Therefore, we expect them, the bonding, to occur in a particular way. And this is going to assist us to predict whether where specifically in this particular compound the reaction is going to take place. And basically, we're going to look at this set of compounds which we had mentioned in our introduction to organic chemistry, which basically form a large portion of organic compounds. And we're going to include also other aspects like the heteroatoms for halides and others like phosphorus and sulfur whenever a need arises. So this particular case for the periodic table, we're going to see that for the trend in electronegativity is going to increase for the first two rows of the periodic table, and this trend is going to increase in the direction of the arrows as indicated in that particular case. But for the sake of quantifying this electronegativity, we're going to use the Pauling scale, and I'm going to mention just a few of these, particularly in trying to see how this particular trend for the electronegativity in this scale can be able to assist us interpret this particular explanation that I've given. So in this case, I'm going to have a scale of a few elements. So if we try to look at the scale that I've given on this lower part of the board, we're going to see that in this scale, carbon actually appears at this specific point with a scale of 2.5. And we're going to see that most of the heteroatoms that are indicated for X, therefore, are going to be more electronegative as compared to carbon. So therefore, if we were trying to consider this kind of bonding, then therefore we're going to allocate polarity for a partial positive charge for the carbon. For most of these, of course, heteroatoms that are appearing towards the right side of the scale as we move from the left to right as shown. So this is increase in electronegativity. So therefore, this is going to, but this particular set of heteroatoms, therefore, we're going to indicate a carbon atom with a partial positive charge, since it's going to be less electronegative as compared to most of these heteroatoms. So in case, of course, we are trying to indicate this, then therefore it's going to appear as such. So therefore we are going to indicate the polarity using that specific notation, and therefore this is going to be sigma positive negative, so indicating that this is more electronegative compared to carbon atoms. So this is going to dictate on what kind of or where the reaction is going to take place, especially in organic compounds. And this, of course, we can just give specific examples, but we're going to see that in this particular case, most of the heteroatoms that I've listed are going to display this property whereby carbon is more electronegative. But for the case of metals, we're going to see that this is going to be reversed, since they are going to appear mostly on this left side of the scale, and therefore they are going to have a negative connotation as compared to this one. And perhaps we can just give an example of magnesium, which is going to be a less electronegative compared to carbon. So for magnesium, then therefore it's going to have its dipole, of course, polarity illustrated using a partial positive charge for the metal, and carbon is more electronegative compared to that metal. So this is going to have its dipole, of course, our polarity indicated as such, and therefore this, of course, effect is going to be described as an inductive effect, of course, that is going to operate through end-to-end interaction of atomic orbitals that we had referred to as a sigma bond. So therefore, whenever we're going to have this particular case for organic compounds, which are going to have a head-to-head interaction with this particular case for heteroatoms and metals, therefore we're going to see that this is going to be referred to as an inductive effect, which I've basically said that it occurs, or rather it's going to operate through the sigma bonds in molecules. So I can just give a few examples of these particular bonds which are containing the dipole, so that in any case we come across them, then we can be able to allocate or identify the direction in which reactions are going to, or the particular points in which reactions are going to occur respectively. So suppose I have a carbon in carbon that is just appearing as such. We say that carbon is less electronegative compared to oxygen. Therefore, we're going to have this specific dipoles indicated as this partial positive, partial negative. Now, suppose we have a bromo group. Still, it's going to have this specific illustration for this dipole indicated as the partial positive charge and partial negative. So we're going to have these moments illustrated as such. And for the case of course, double triple bonds, we're going to see that the localization, or what we refer to as resonance, is going to also contribute to the overall effect of this polarity. And for that case, still we can just give us an illustration for the double bond for the CN junction, which is going to be illustrated as that. But for this case, still the hydrogen atom is going to have a more positive charge as compared, or it's going to be less electronegative as compared to nitrogen. Therefore, the moments will be illustrated as such. And basically, this is going to form a basis for us in identifying or assisting us identify whether or predict where most of the organic reactions are going to take place. Now, apart from this, of course, we're going to look into specific examples, or maybe in our discussion on organic reaction, therefore we're going to identify specific areas, especially the concept of a charge that I've mentioned. And this particular case, it's going to assist us identify where charges are going to move to, especially when we're going to talk about the mechanisms in organic synthesis or organic reactions, as I've said, as an overall concept. So in this case, I'm just going to stop there. I hope that this particular discussion will assist us in trying to identify different behaviors insofar as electronegativity is concerned in when it comes to the concept of bond polarity. So I hope that that one is understood. Kindly check on our description box and engage us, and also subscribe to our channel of Honest Sciences and Mathematics TV channel, so that we can have a more elaborate and a healthy discussion. So that is it for now, guys. Bye. God bless you.